In 1986, Acorn Computers launched the BBCMASTER 8-bit home computer. It was the successor to their hugely popular 1981 BBC Micro, which won the BBC's computer literacy contract aimed at educating the public about microcomputers and programming. It had greater performance, more RAM, improved basic commands, graphics and sound. So let's open it up, fix what we need to and review this powerful and versatile home computer. At nearly 48 by 35 centimeters, this large footprint computer houses an array of interfaces, starting with these two cartridge slots, an Acorn developed networking interface, an audio out jack, a cassette port which used the computer user's tape standard, a serial communications port which used the RS423 standard, an analog interface for sensor input, digital, red, green and blue synchronized video output, analog, composite luminance and chrominance video output, standard coaxial radio frequency video output for older TVs, and a cabled power input rocker switch. However, underneath we also have a second processor or coprocessor expansion interface. Inherited from the original BBC Micro, we have a slow speed interface which connects peripherals directly to the system bus. A 2-control line 8 bidirectional data line interface, a printer interface, a disk drive interface, and finally an auxiliary power output featuring plus and minus 5 volts and a plus 12 rail for low voltage peripherals such as modems and drives. On the base we have this label, however there's no serial or model number. So let's open it up and see what's inside. On the system board, we have a battery backed up memory chip that stores system configuration settings, a custom ULA video processor which manages 7 varying raster graphic modes and 1 teletext compatible text mode. The processor, based on the CMOS 6502, runs at 2 MHz. The machine operating system ROM contains the core system firmware. The advanced network filing system ROM manages file transfers, 2 VIAs, this one for internal system operation, and this one manages the printer and user ports. The floppy disk controller, the sound chip which provides 3 square waves and 1 noise generator for effects like explosions, and 128K of RAM. But due to 16-bit address bus architecture limitations, we can only address 64K. which by default is split into 48K of RAM and 16K of ROM. However, by updating the access control configuration register, we can access additional shadow RAM. And updating the ROM select register allows us to select one of 16 16K sideways RAM or ROM banks. Furthermore, we can hardware select additional RAM or ROM for slots 4 and 5 using this jumper from this socket, and additional RAM or ROM for slots 6 and 7 using this jumper from this socket. This Watford Electronics daughterboard is the EcoNet module, which was Acorn's proprietary networking system. The underside of the system board is clean. However, due to issues with CMOS battery recharging, this factory fitted resistor was fitted to disable this function. So let's remove the power supply unit, look inside and fix what we need to. As the battery backup, which maintains the CMOS system configuration settings, has seen better days, let's replace the battery holder with a modern one, clean it up, install new batteries, and reinstall the power supply, system board and CMOS battery backup. The keyboard appears in good shape and has an assembly date on the back. Removing one of the keys reveals nearly 40 years of grime. So let's remove all the keys to clean and future-proof this retro keyboard. During the restoration, I came across this USB power supply kit, which comes with all ground, positive and negative volt cables, retaining spare sleeve and fixing. So let's install this modern solution to further future-proof and finally close up this fully restored BBCMASTER ready for testing. Powering on the Master displays the error CMOS RAM reset. This is because the CMOS has lost its configuration due to the battery losing its charge. Pressing R when powering on enables us to reset the CMOS configuration, and using the status command, this confirms everything is set to default. Using the ROMs command displays all available ROMs which are stored here, with the exception of the ADFS ROM. So, with this information, let's replace the existing key strip with one that references our ROMs. And configure our default language to the basic ROM, or 12 in decibel, which means we can now run basic programs. This Cumana dual 5¼ 40 or 80 track and 3.5-inch floppy disk drive is compatible with both DFS and ADFS formats. So let's open this up and fix what we need to. To test this dual drive, let's place the master under this stand. Connect the disk drive cable. Locate the dual drive on top of the stand and the monitor on top of that. The disk filing system was developed in 1981 by Acorn computers, which initially supported 40 tracks and then 80 from 1986. So let's insert a 5¼ inch floppy disk and see what's on it. Nothing. And that's because we need to format the disk as DFS 80 track using the Form 80 command. Let's perform a catalogue listing of our floppy disk to load a basic program I wrote previously, which cycles through all available colours for each graphics mode. In 1986, ADFS2 was introduced, adding functionality such as nested directories, verify and backup commands, and copy the original using ADFS commands. Having mounted the 3½ inch floppy disk, let's perform a disk directory and load a few notable images. The Master SD cartridge allows you to download software images from the internet, and a sample can be found on their website here. After copying the files over and inserting the SD card, let's load the modern MMC file system ROM and load up the sample image. Navigating back to their website, we have a user guide which explains the process to load more software images. And if, like me, your install required an OCX component, you can find it here. Once installed, you can download your software and append it to your original image. So let's connect some external speakers to the audio out jack and load up the menu.